Hi, in this video we're going to find a formula for the inverse of a non-zero complex number alpha. So let's go ahead and just do it. Solution. So let's go ahead and write alpha in a different way. So let's identify the real part and the imaginary part of alpha. So because alpha is a complex number, we can write it as a plus bi, where a is called the real part and b is called the imaginary part. All right, so we need to figure out a formula for the inverse of this, assuming that this is not zero. So let's just go ahead and do it. Watch this. So alpha inverse, well, that's the same thing as 1 over alpha. And so the trick here is to multiply by the conjugate of alpha. So recall that the conjugate of alpha in this case is simply a minus bi. Right? You just basically switch the sign. So to do that, we'll multiply by the conjugate of alpha over the conjugate of alpha. We're basically multiplying by 1. And again, alpha here is not 0, so there's no issues. So this is equal to alpha conjugate over alpha alpha conjugate. Now, there is something important about this. Recall that if you have a complex number alpha and you multiply it by its conjugate, that's a plus bi, a minus bi. And if you multiply this out, this ends up being a squared plus b squared. So this is actually equal to the conjugate of alpha over a squared plus b squared. So a couple different ways to write this. So one way to write it would be that the inverse of alpha is simply the conjugate of alpha over a squared plus b squared. That's a pretty good way to do it, and I like that way. This is something special though. If you have a complex number alpha, written in the form a plus bi, it turns out that the absolute value of alpha, also called the modulus of alpha, is equal to the square root of a squared plus b squared. So this formula is actually the conjugate of alpha over the absolute value of alpha squared. So two different ways to come up with the formula, or two different ways to write the formula. I hope this helps.